Okay, so where we left off was on 7C, about to break things into the components. So this is f1x, this is f1y, this is f2x, and this one is f2y, and then we have another vector here, f3x, and f3y. Okay, so this time the only difference is you have three different components. So f1x will be, what is that? I can't even see. It is 48 newtons. I wonder if I can make this bigger so that we can all see. 48 newtons. And x, it's cosine again. So cos of 81. And we get an f1x to be 7.15 newtons west. F1y will be 48 newtons sine of 81. So F1y will equal 47.41 newtons, and that will be north. F2x, also cos, so 61 newtons cos of 63. So F2x will equal 27.69 newtons. That's east. Box these so I can keep track of them. And so that means F2y is sine, so 61 newtons sine of 63, and you get an F2y of 54.35 newtons, I think it is, and that's also north. And then the last one, F3x, it is also going to be cos, so it's 78 newtons cos of 15. And so you get an F3x to be 75.34 newtons in its east. And F3y, 78 newtons sine of 15, and you get an F3y to be 20.19 newtons, and that is going to be south. Okay, so again, you just find your total in the x and your total in the y, only this time you're adding up 3. When you do the total in the x, it ends up being 95.3 newtons, and that's east. When you do your total in the y, it ends up being 81.57 newtons, and that's north. Okay, so then you make your new triangle with these two guys, east and north. So we'll do it over here. One going east, the one going north. It's just a little bit shorter, so this is 81.57 newtons. This one is the 95.53 newtons. Okay, and then here is your F net and your angle. So when you square them, add them together, and take the square root, you get an F net of 125.62 newtons. And your angle is going to be just a bit less than 45 because they're not quite equal. So 40.49 degrees, and that will be east-north. So your F, what would this be for? Your F4 or your equilibrium will be 125.62 newtons, and instead of east it will be west, 40.49 degrees, and instead of north it'll be south. Done. Okay, so hopefully these are getting easy by now. All right, there's two more that were for homework, and really they're the same. Well, the next one's the same. You just had to read it because it's a word problem about kids pulling on a teddy bear. But same kind of idea. Just be careful of the angles this time. Okay, because this time Amy is pulling north 58 degrees east. So she's pulling this way, and the angle is here. and this is the 15 newtons. And Buffy is pulling south 23 degrees east. So she's pulling this way. The angle is here, 23 degrees, 18 newtons. Why does that matter? Because it's going to change your sine and your cosine. Here's F1y, here's F1x, here's F2y, here's F2x. And this time when you do F1x, it's going to be sine. So F1x is going to be 15 newtons because it's the opposite sine of 58. And F1y is going to be 15 newtons cosine of 58. So just be careful when you do this that you don't get your sine and your cosine mixed up there. So when you do it, your x is going to be for 1, 12.72 newtons east, and your y for 1 is going to be 7.95 newtons north. And then when you do it for Buffy, your F2x is again going to be cos 18 newtons cos of 23. And your F2y is going to be 18 newtons sine of 23. So you get an F2x to be 7.03 newtons, and that's east. And you get an F2y to be 16.57 newtons, and that's south. Okay? So if you mess this one up, my money would be on right there, because now the rest is the same. Once you get those right too, do the total in the x direction, 19.75 newtons east, total in the y direction, so you end up subtracting them, 8.62 newtons, and that's south. And so then when you draw, you're going east, 19.75 newtons, you're going south, 8.62 newtons. Here is your F net, here is your theta, square them, add them together, take the square root, 21.55 newtons, and the angle will be 23.58, I think, 23.58. It's going east first and then south, and so that means the third kid has to pull with 21.55 newtons west, 23.58 degrees north. Final answer. Okay? Now, we're going to run out of time before I get to finish this one. But number 9 is a little bit different. Number 9 has light hanging down. And so if you think about the forces at this point, this is Fg going down, and you can find it. It's just mg. So it's just going to be 65 kilograms times 9.81. And then you have two Ft's going up, Ft1, Ft2. And these two going up, they have components. They have an Ft1x and an Ft1y. And this one has an Ft2x and an Ft2y. Well, the Ft1x and the Ft2x should just be equal and opposite, because this light isn't moving back and forth. So Ft1x should equal Ft2x if it's hanging in equilibrium. Oops, x. Okay? And in the y direction, Ft1y plus Ft2y should be equal to Fg, right? Because it should be balanced out. And so then you can find what the Ft is. This would be also 12 degrees, right? Alternate interior. So Ft1y is really just the opposite side. So it would be Ft1 sine theta plus Ft2 sine theta would equal mg. But despite my diagram, this is actually symmetrical. So these two Ft's would be totally balanced because the angles are the same. So Ft would be equal to Ft. That's what actually this tells you right here. right? Because the angles are the same. So really